Welcome to MEERTALK. My name is Kaeza Fern, your host for MEERTALK. We are very glad to be getting together again this month. And today we're going to be hearing from Eliot Jacobson. Then we'll take questions from people in the MEER community, and then we'll open it up to questions from all of you. In case you didn't see our recent November newsletter, the MEER Fabrication and Engineering team is demonstrating the practical applications of sustainability in urban heat management through their cooling canopy project in the Aberdeen Roundabout in Freetown. In order to carry out all of the projects crucial for MEER's further development, we really do rely on donations. If you haven't already donated and you'd like to contribute, you can go to meer.org/donate. And thank you so much for your contributions. You could also write to info@meer.org to be in touch at any time. Now, let me tell you about our guest speaker. Eliot Jacobson is a retired professor of mathematics and computer science, as well as a consultant to the casino industry. In his retirement, Eliot has focused on science communication and volunteerism. If anybody has any questions that come up while Eliot's presenting, you can send them along to co-host Kathy in the chat. Okay, Eliot, well, thank you for coming to talk with us, and we are very excited to hear what you have to say.
Well, thank you so much for having me on. I'm very honored to be presenting to you and to this group. I've been a longtime fan of the MEER organization, so thank you again. And just to sort of let you know, my background is in mathematics, a PhD professor of mathematics. I have pretty much obsessed over numbers my whole life. When I was 8 or 9 years old, staying home from school because I was sick, I was doing multiplication tables just to pass the time. You know, I was listening to weather forecasts and tracking the daily numbers since I was 5 years old. I don't know, it's just been something. So what happened is that the Paris Agreement came around, and let me just sort of go right to the share here. I'm going to do a PowerPoint, okay? So we will get down to the meat of this. So here is the upshot. The problem is in the Paris Agreement itself. This is what this talk is going to be about primarily, is Article 2A of the Paris Agreement, which reads, holding the increase in the global average temperature to well below 2C, above pre-industrial levels, and pursuing efforts to limit the temperature increase to 1.5C above pre-industrial levels, recognizing that this would, and so on. So, I mean, that's all very good. And you would think, okay, we know exactly how to measure 2C or 1.5C. Surely that's also included, or there's some standard way that this number has been computed and everybody knows that that's the way we're going to do it. And so I went looking for that, right? And what is that? And you know, you start talking to people and they just give their own definitions of that number, right, left, and sideways of how, and everybody thinks that the IPCC has somehow defined this, but the truth is they haven't. And the Met Office, there's an article that came out that has this quote in it. This is from December 2023. Writing in the journal Nature ahead of COP28, a team of Met Office scientists has emphasized, surprisingly, there is no currently formally agreed way of defining the current level of global warming relevant to the Paris Agreement. I mean, it should just sort of like what? It just was crazy. So I went in search of an answer, like any answer to this question. And what I want to do is sort of give you some context for what's gone on in my search before we get to some answers. So before I do that, I'm going to invite everybody here to sort of choose what they think the answer to this question is, and more broadly, to sort of imagine if I were to conduct this survey, what percentage of people would choose each of these categories. So this survey is how much has the planet warmed with respect to the 1850 to 1900 IPC pre-industrial baseline. This is long-term warming as it's considered in the Paris Agreement. So in your own mind, choose one of these, and in your own mind, try and picture a distribution for the answers to this question. So I will come back to this after I present a little bit of other background material. So first of all, I just want to take you through some of the perspectives that people have. And this is from social media. This first post says, it really shows how the 10-year average used by the IPCC doesn't work in a world with nonlinear warming. So this is a person who knows it's a 10-year average, right? That's their assumption. Copernicus, right? The Europeans say, if you actually read this one, they say down at that last sentence, they say the agreement applies to a long-term average of at least 20 years. So again, both of these are talking about averages, right? The key is they're saying an average as opposed to a trend. Let me just say to distinguish that. And then again, just some random post down at the bottom where this person is lamenting the fact that it will take 30 years before we can verify that we're at 1.5 C because, you know, it's got to be 15 years on either. It's going to be 30 years in the future. So you see how confused people are. I mean, this is one of the great failures of climate communication that's gone on here. Now, let's just look at some sources here. Here is the US, climate.gov. And just to sort of pinpoint this, the first thing is they are claiming that we currently have a 0.2 per C per decade rate of rise in global temperatures. But on the lower right there, their claim is that there's roughly a 2-degree Fahrenheit, 1 degree Celsius increase. All right, they published this in January of this year, 1C. All right, I asked Gemini AI the same question, exactly the same language. Gemini says 1.1 C. All right. Now let's go to some mainstream media. Here's Bloomberg from 2020 saying we're at 1.2 C. Here is Dr. Gilbs, I think is how you say her name. She has a fabulous YouTube channel. And this is the one that really got me started. And this is, I did all my math based after I saw this YouTube video. And this is again from, I think it's January of this year. And she said, quote, given that temperatures have already risen by 1.26 degrees. And, you know, it was the accuracy of that claim. She just sort of said it sort of right offhand as if you could just be accurate to the 100th of a degree. And, you know, that was the answer. She didn't say how she got that or where that number came from or anything. Now, Copernicus just recently put out this graphical method where they actually use a linear trend line, unlike an average that they stated earlier. Now here they are using a linear trend line. And if you sort of go to their graphic and look at this very closely, you'll see that what they're saying is at the end of 2023, if you like January 1st of 2024, we are at 1.31 C, right? So, and then we have James Hansen, right? I mean, here again, the beginning of this year. So basically at the end of 2023, he's saying that it's clear at the bottom there, it will be clear that the 1.5 ceiling has been passed for all practical purposes. In other words, why are we even talking about this? We've blown through 1.5, right? According to him. And by the way, he often also will say something like we have between 0.4 and 0.5 C degrees of warming per decade. So all of these things kind of got to me, right? I mean, I was like, what's the answer? What is the answer here? All right, so I asked this question on Blue Sky last week, and this was the actual distribution of responses. So you'll see the modal response is that we have already passed 1.5 C, right? That we're already above 1.5 C. And, you know, there's some people who think we're already above 2 C. There's at least one very famous doomer out there who has a YouTube channel I shall not name who thinks we're above 2 C already. So it's, you know, there are some people who think that. At any rate, to me, this shows a great failure in climate communication, right? Because 1.5 C is so ingrained into our conversations, into our dialogues with each other. To have so totally failed at this, where we can say that we have to stay below that number, but we don't have any way of computing that number that's agreed on. We don't have any consensus on what that number is. So that's what I want to talk about here today. So my personal research is based on Copernicus data, right? That's where I mean, you have to choose some data set, right? So there's Berkeley Earth and there's MET and there, right? So I do everything based on Copernicus data for two reasons. One is it's really easy to access if you don't have like an official account, right? You can just get it right online as a text file. And the second is that they have a very precise definition for the 1850 to 1900 baseline that they've also provided sort of freely to the community. So you can do your own work on this, right? I mean, I'm just a guy sitting in a garage in Santa Barbara, and I have access to this data. And I go to it every single day. Now I want to go back to that Copernicus linear trend model because I want to show you an answer to this question. But in order to understand the answer, you have to see what happens. And they just put this up 2 weeks ago. And this is a fabulous tool that they have. Essentially, what they do is they let you grab any 30-year period and draw a trend line based on those 30 years of data. And this dates back from 1970 up through current data, right? And each dot is a month. So their trend models are based on monthly data. And so if you look at the first 30 months of data, then draw the trend line, we break 1.5 in December of 2041. If we do sort of a middle ground trend line, which is the middle image there, we break 1.5C in November of 2038. And if we use sort of the most recent data, we break 1.5, let me see, in January of 2030. And so when we're talking about trend lines, the assumption is that a line is the best fit to the data, right? There is that ingrained assumption. Now, there are all sorts of methods of figuring out, some way of putting a trend into data. But fundamental is if there is a curve, a polynomial curve or an exponential or a logarithmic that through what you know about the real world should fit the data, then you're obligated to use the right type of curve instead of, say, lowest smoothing, for example, some more sophisticated technique of sort of tracking the data. And so for those of you who like calculus, what we have here are tangent lines that are getting steeper from left to right. So the slope of the line is increasing. So the derivative is increasing. All right, from left to right. Now, if the derivative is increasing, it means the second derivative is positive. And as you all remember from your freshman calculus, when you have a positive second derivative, that means you have a quadratic fit to the data. So what we see even in Copernicus is that the right thing to do here is to use a quadratic fit because warming is accelerating. And warming is accelerating. There's no question but that warming is accelerating. And you can find all sorts of mentions of this, but this one just came out this last week or month, right? This article. And let me just read the bottom highlighted part to you. The issue of whether climate change is accelerating has sparked heated debate in recent months. Here we examine for acceleration and warming rates and explore possible causes for regional differences. We find the rate of global warming is accelerating and show that regions with large populations and low socioeconomic development experience reduced acceleration due to high local aerosol emissions. So the conclusion is there is acceleration, and it varies regionally, sort of how much dirty fuel you're burning. That's and what they're saying is that the heating in those places is going to accelerate even faster once we go to an energy transition where we're not using these dirty fuels anymore. So there's another reason we know that warming is accelerating is that's the Earth energy imbalance, right? The difference between incoming solar radiation and outgoing radiation of all types, some reflected, some thermal. So if you look at the difference between incoming and outgoing radiation, and I've measured this in terms of the equivalent in Hiroshima bombs worth of energy per second, you see that we are increasing the rate at which the planet is heating. Now, in order for global warming to be linear, you would need to have a constant rate of heating, right? And then you would expect the rate of temperature rise to be relatively constant. But because we are actually turning up the flame over time, the heating is getting faster and faster. So, I mean, this is tangible evidence on top of that research paper for accelerated warming. Now, this is the Copernicus data directly from my spreadsheet. And I'll just, someone can go back and check this out at some later time on a freeze frame, if you want to see what this stuff actually is. But what I do, the left-hand column under GMST is where I type in the daily global mean surface temperature. And the column to the right of that one is the actual IPC baseline temperature for that day. And yes, I'm using 3 decimal digits accuracy because that's what's been given to me to use, right? I will round down to 2 digits at a later time. But if you're going to give me 3, I'm going to go with it as long as I can. And so this is sort of how I keep my data. And when I plot then the monthly data, right, this is using the Copernicus method of plotting monthly data. When I plot that monthly data, and rather than having a linear curve associated with that data, I allow myself to have a quadratic or accelerating curve. You see, this is the fit we get, right? And you see it's a long-term fit because the tangent at any point to that quadratic curve, the tangent line at any point to that quadratic will just be that linear fit that Copernicus was giving you for that chunk of data. So in particular, let me point out 2 things. First of all, if you go to the first arrow on the right-hand side, that's 2024. You see we are just slightly under 1.4 C as of the beginning of this year. So whereas Copernicus with their linear model said 1.31, this model says 1.38-ish, right, for the 2023 global surface temperature. Moreover, if you follow that to the right, you see that this also predicts that we are breaking 1.5 in 2027. All right, so once you accept accelerated warming, things are happening much faster. And you've got to accept it. And there's another method we can do to get to the same result that I just want to share with you. So that same paper that I quoted from earlier by Richard Betts saying that we don't have a method, in that he suggested a method to compute this number. And here is the method that Richard Betts suggested. Today, we are recommending an indicator combining the last 10 years of global temperature observations with an estimate of the projection or forecast for the next 10 years. In other words, what he is saying is to find today's average, we take the previous 10 years, we take what our model predictions for the next 10 years, we do a straight average of those. We're not doing a trend line, we're just doing a straight average of those, right? The previous 10 and the forecast next 10, and that'll be the temperature today. And that is the method that they use to come up with this 1.26 C that Dr. Gilbs quoted in her YouTube video. This is exactly the method that she used. So why did she get this lower number? Well, it's a different data set for one. They may have different model projections than what I'm going to use. They may have a different baseline than the Copernicus data, right? So at any rate, they used a method that you have to say, yes, this is good, right? This is at least a method that makes sense and could be adopted. So I did this method as well. And so what I want to do is show you how I followed that method. Well, we already know the previous 10 years, right? I don't have to worry about that. The question is, how do I predict the next 10 years? And the answer to that is I do it by understanding decadal warming, right? I want to know how much warming has happened in a decade. Now, the Met assumed that there was 0.2 C warming per decade. You might remember I quoted that number. So what is 0.2 C? What's the problem with saying there's 0.2 C warming per decade? Well, for one, that number is too low. And for other, they're assuming that that number is staying the same. But if warming is accelerating, that means the decadal warming must also be increasing with time. So what this graphic represents is I took every day's temperature. Then I took the temperature from exactly 10 years previous. And I took the difference between those two temperatures, today and 10 years ago, right? Yesterday and yesterday 10 years ago. Yesterday -2 and yesterday -2 10 years ago. I took those decadal differences and I graphed them here. So every single point on this graph represents a delta, a temperature difference over a decade. And what I did was to say, okay, here's the decadal planetary warming. Now, does that have a trend line? Right? So does that have a trend line? And yes, it does. And when you really track down that trend line of the decadal warming, what you find out is that we are currently at 0.3 C of warming per decade. I wish I could point to it right here. I guess I probably could use a tool or something to point to that, but you can see that, all right? We're at 0.3 C warming per decade right now, but even more than that, that line is going up. That trend line is going up. The rate of warming is increasing. So decadal warming itself is going up. And how much is it going up? By roughly 0.005 C per year. And what does that mean? It means this year is 0.3 warmer than last year. But 2025 will be 0.305 C warmer than 2015. And 2026 will be 0.31 warmer than 2016. And so on. 2033 is going to be 0.345 C warmer, and so on up to 2034. So if you accept that there is this decadal warming, this trend line for decadal warming, it tells you how to predict the future temperatures based on the temperatures from 10 years previous, right? This is the best fit, this linear fit. So when we simply do that, guess what we get for an answer? We get, once again, 1.38 C above the baseline. So that's my answer, right? My answer is 2023 was 1.38 C above the 1850 to 1900 IPCC baseline. All right, the future. And this will be the last little bit of the talk. Then we'll open it up for questions. Here's the problem. The problem is that a trend line is not the best fit for the decadal warming. All right? It's actually, decadal warming is also accelerating. The acceleration is accelerating. Now, it gets a little bit complicated, but what that means, if you like calculus, is that the third derivative is positive. And for those who like words that go, kind of geeky math words, that means we have jerk going on, right? Jerk is when you have a positive third derivative. Look it up. That's really the word out there for the positive third derivative. Now, just to be clear, exponential growth means all derivatives. Infinitely many derivatives are positive. We're struggling to get a positive third derivative here. Temperatures are not increasing exponentially. Temperatures are certainly not going up linearly, they're accelerating. They may be going up a little tiny bit faster than accelerating. In particular, that number I use, 0.30 C, you notice that when I allow myself to have a quadratic fit to the planetary warming, that 0.3 C actually goes up closer to about 0.34 C. And the rate of rise is going up faster as well, which means that warming is probably even faster than, it's slightly faster than the quadratic trend line that I showed, which means we may get to 1.5 slightly earlier, right? We may get to 2 slightly earlier based on this model if I were to use this particular interpretation. So what I did, as this is what I do, I I have a life in the casino industry, is I think of when you say how hot is it, it's sort of beside the point to say last year was 1.38 or this year is going to be 1.41, because we know this year won't be 1.41. This year probably is going to be closer to 1.58 based on the latest data for the entire year. So how is this data meaningful? How are these projections meaningful in any real sense? Well, as somebody who comes from a casino background, they're meaningful in the sense that they allow me to draw what I consider to be 50-50 odds of future temperatures, which means right now, if you were to place a wager on 2025, the over-under is 1.44. In other words, I am predicting roughly a 50-50 chance that will either be hotter or colder than 1.44. And if you look at 2027, the over-under is 1.51, right? And if you look further over, you see that the year 2041 has an over-under of 2.01. Now, I created these odds at the start of this year. I do expect that I'm going to redo this based on having another year's worth of data. I will redo this in January, and I'm expecting that everything is going to shift towards being hotter faster after I redo these numbers. So that 2.0 might come in the late 2030s. There's a slight chance that 1.5 could come in 2026. I won't know until I redo all this math, but I think of this as the right way to look at these numbers when you're looking towards the future, is you want to be able to say, based on all this work, you don't want to say, oh, last year was 1.38. What you want to say is there's a 50-50 chance that will be over 1.5 in 2027, right? That's the type of sort of more meaningful language that these types of computations can help you do. In particular, on X, and I'm not on X anymore, so this is now deprecated, but I actually have these sort of fake polls that I do, right? These fake gambling bets. And so when I come up with a computation like this, I will put that up there, right? The Climate Casino is offering an even fake money bet on 1.45, right? So since my line was 1.44, what I'm saying is the over is 1.45 and above, the under is 1.44 and below. And what you see is that most people take the overs on these. Most people out there, and again, this is part of this problem with climate communication. Most people have not thought through these things very carefully, and they think it's going to get hotter faster than I personally really think it is going to get, right? A lot of people have these sorts of over-the-top doomer, it's going to happen, this year or next year. It's going to happen, but there's still some physics out there that's kind of still in control. We're not completely into chaos yet. And just to sort of make the point, I asked Zeke Housefather which side he would take on this bet, and he said he would take the under. So, it's the line that I have, and I think the smart money's on the under bet right now. Of course, it all has to do with whether a La Nina starts or not. So one last thing going on here, as far as the long-term future, you may have seen this slide. It was going around for a while that 380 IPC climate experts were asked, how hot do you think it's going to get by the year 2100? And, I'm not sure how people thought it was going to get below 1.5 C, who that is, but 6 out of the 380 actually we're optimistic we would stay below 1.5. I think overshooting 1.5 is a given now, but what I did that was not in this was to actually figure out the mean of all this data. So the average IPC climate expert thinks we're heading to about 2.7 right now. So I can't do any better than this. I mean, I feel like I can give you odds up through about 2050. But, there's all these tipping points, there's all these feedback loops, there's the AMOC, there's a methane burst coming out of Siberia. There's all sorts of things that could happen. The Amazon could tip. So I'm not really comfortable going beyond 2050, where even then I'm stretching my quadratic interpolations to their limit by going that far. But some people are willing to make those estimates, and this is what we come up with. So, all right. And just last, if you want to visit my personal website, my blog, this is where you can find it. And you can actually find the article I wrote where I present all this information from last January on my blog, climatecasino.net. So that's everything I have to say in my main presentation. So thank you all so much. And I'm looking forward to the discussion.
Well, thank you so much, Eliot. And next, we are going to bring on somebody from the Mirror community who will ask you a question or two. And just a reminder to our audience that you can send your questions to Kathy Posey in the chat, and then we'll get to those a little later. So Samuel Eaton is a student studying engineering at UC Berkeley and working on community projects. He believes that the best engineering happens when it's closely connected to the people it impacts and addresses social political dynamics in tandem with technical ones. In his free time, he enjoys rock climbing, reading, and cooking. And thanks for coming on, Sam.
Thank you so much. So I first have a question that kind of zooms out from the technical question for a little bit. And it is, do you think the effectiveness of Article 2 of the Paris Agreement is kind of primarily dependent on the specificity of the standard? So like, in other words, if we have a more clear standard for measuring warming, to what degree will we be able to more like significantly mobilize towards it?
So if you didn't know the value of pi, since you're an engineer, and you just knew it within 10%, somewhere between 2.8 and 3.4, you would have trouble building a lot of things. I think it's critically important because it is a number that the world is focused on, obsessively focused on. It's always about we need to stay under 1.5. We've got to keep under 1.5. It is the defining number of the climate movement, the climate politics, right, worldwide. So yeah, maybe there's a lot of numbers we shouldn't that are not as important to know about, but the failure, you see the failure over and over because if we can redefine that number at any time, we need to in order to be able to delay action, right? If we feel like we're not going to make it in time, well, just make it the last 30 years average, right? So that brings it down, and now fine, we can have another 20 years of fossil fuel burning. So yeah, it's really gives permission to abuse the system by not having a clear definition.
Right. So adding a more specific clause in the Paris Agreement would, in a sense, give more like accountability or like make them more responsible for holding them to a standard, right?
So yes, 1.5C, comma, as defined by, right? Some the World Meteorological WMO or something like that, right? As defined by, as presented in the yearly report of the, right? So that there's some standard. But Leon Simons had a great statement when I was talking about this with him. He said that if there were a clear definition of this number in the Paris Agreement, then the Paris Agreement would have never been signed. I mean, there's a lot of truth there, right? That it was the ambiguity that gave the room for people to sort of stretch their willingness and to get that sort of unanimous consent.
Interesting, really interesting. Okay, and then one other question is that I see that you're also more into politics. So given that Trump withdrew from the U.S. Withdrew the U.S. from the Paris Agreement during his first term, and now holds presidency again, should we anticipate more disruptions to environmental policies? And do you see any specific kind of policy changes or anything specifically that we should see or look for in the next 4 years?
Yeah, I mean, of course, that could go into the computation of the future as well, this sort of issue. Now, with respect to the Paris Agreement, a lot of these things are already in motion. I mean, there a lot of industries have already sort of set up new green standards and are doing their own transitions, right? There's certainly it's going to be very challenging to just have industry do a right turn again. But there are some very critical components of the transition. For example, the electric infrastructure, right, which is sort of lagging behind the sort of home solar, home battery, right, the ability of the grid to take this energy and know how to store it for more regional. So these sort of larger infrastructure components that are necessary in this country are certainly going to be put on a back burner during his presidency. But I don't personally think that there's a lot that he can do all by himself. I mean, the Inflation Reduction Act was a law. Laws are passed by Congress. Congress has discretion, the ability to spend this money. There's very little discretionary, part of that. So there is a sense in which will Congress go back on this? Is Congress going to be the agency that actually takes action against the Paris Agreement? Well, about 75% of all the money from the Inflation Reduction Act actually has gotten sent to Republican districts, right? House districts. So, I mean, they really have gotten the majority of the funds out of this thing. So, it's kind of unlikely that Congress is going to, especially the Republicans who are, anti-climate change, are going to want to vote against money for their own constituents, right? Where there's green jobs, there's new factories being put up to make batteries or whatever. So there's sort of a momentum here that's going to be really challenging for Trump to sort of stop in its place, which I think is a fear. I'm much more fearful personally of issues surrounding immigration and women's rights and education and sort of a whole realm of social issues. The climate, I don't think is going to be impacted as much as we think it is, right? I just don't think it's going to be that left turn the way we might see in some of the other social issues.
Right. So, like, in a sense, the kind of practical implications of like climate policies we have in place right now, like the more green jobs as such, are going to outweigh the maybe more ideological wants of Republicans, in a sense. Is that something like that?
Yeah, and I'm not a policy expert on this sort of thing in any sense, but there are some real problems right now in the solar industry, for example. You may or may not be aware of some of these things, but both of my kids are involved with the solar, and they sort of got upside down. They took out a lot of loans based on growth that hasn't necessarily appeared, and so a lot of these sort of smaller solar companies are going bankrupt, and you see that happening a lot. So I mean, there's sort of a transition happening anyway in the emerging industries, and I think what we will see is that we're not going to have the federal support for those the way we did. I have to say, I don't think I've made this point very clear here that I'm not necessarily pro-solar, pro-wind, and pro-alternative energy, right? I am pro-environment. I'm an environmentalist, first of all. And so, when you talk about opening up new lithium mines or opening or putting wind turbines on the top of mountains, it's not something I'm particularly would like to see. Of course, I don't want to see new fossil fuels drilled either way, either. And so at some point, we're going to hit this cliff. And the question that I always come down to when these sorts of questions come up is how little damage can we do in the long run? What's the right path to take to cause as little total environmental damage as we can? And so I'm not fully settled on what the answer to that question is.
Okay, thank you so much. That's it for me.
Thank you, Sam, for coming on. And we now are going to take a couple more questions from the community. And I have a question that's come in from Jonathan. Jonathan says, in your monthly data point chart with the blue background and the quadratic fit line, the fit line only works into the future if the natural processes that cause the past data points to revert to the mean are still functioning to bring the temperatures down after a skip upward. There is evidence that natural processes that have reduced the rate of warming have now exhausted that activity, and there may no longer be a reversion to the fit line. Do you expect that we will have several years of cooler temperatures, that 2023 and 2024, I think cooler temperatures than 2023 and 2024 in 2025, 2026? Or do you agree that the fit line, even as a quadratic, is too optimistic?
So that is a truly great question, and I'm going to go right back to that. Is that share working? Can you?
Yes, we can see that.
Okay, so this is the graph he's talking about, and what I want you to notice is that the last, let me count them, 3, 6, 7, 8, 9, 10, the last about 18 months have been way above that red line, right? And the question is, should we ever expect that to fall below the red line again, right? Or is it faster than quadratic? Well, I've already told you it's faster than quadratic, right? Because I did further research that showed that it's more like cubic. And you could do a cubic fit, it would be slightly better. Things will still be above even with a cubic fit. But what I want to do is sort of pull you back to 2016. And if you look at 2016, when that's the previous spike, right? And all of those months that were way above that line for that spike, and then they went below after that. And it wasn't a short term, it didn't just happen, right? It took a couple of years. Or if you go back to 1997, you'll see all of those, so this is not the first time we've had a situation like this where temperatures sort of go way above this line, and we ask the question, is that enough? What is different this time, and there's a lot to be said for this, that there are some things that are going on that, Gavin Schmidt and Housefather have talked like it's no longer acting like we thought it was going to, and it might be the fuels, the cleaner fuels from shipping that have changed the aerosol masking slightly, so that this warming is going to be more permanent than we expected. It could be some other tipping point. We're starting to lose, we're at global lows now for ice extent, in Arctic and Antarctic put together. And so we have more open ocean, and open ocean absorbs more heat. And that could be sort of causing a feedback loop that's causing faster warming. All of those are possible, but we cannot say that until that comes to pass, right? I mean, the point of models is that that's what we have. We don't have some magic 8-ball that's going to do better than our models. And what I'm saying is that the models that Copernicus is using are linear, right? All of the other models you may have seen are not keeping up with things. And at least I'm trying to use the best math I can to make an educated guess for the future. And yeah, again, I think these next couple of years are going to be very critical up through about 2027, 28, in terms of seeing whether this is yet another instance like 97 or 2016, or if something truly different is happening this time.
Yeah.
Great question. Really, I mean, that is a key question. That's the question that Hansen asks, right? He said, look, we're so far above 1.5 right now. Even if we come down sort of an equal amount on the other side of the curve, the long-term average will still be above 1.5, right? Sort of his argument that we're so far above, if we have a La Nina and we go down to 1.4, well, the average of 1.6 and 1.4 is still 1.5. And while that might be true, right, the actual, what we need to say where we are is we need a well-defined methodology that is robust and that we can reuse. And it can't be an ad hoc methodology based on what we see happening this year or next year or last year.
Yeah, excellent point. Here's a question from Bryn. Bryn asks, has there been any effort to try to attribute how much of the historical warming is due to decreases in surface albedo? For instance, the shrinking ice caps you were just mentioning, black carbon soot covering the snow, etc.
So I don't know an exact number for that, but I mean, certainly there's a lot of discussion about that. Even, for example, some of these tree planting efforts that have been made, they're planting trees that have darker shades than the sort of the background flora that was there before them. And so, that's increasing the absorption of solar. So, there is going to be eventually this runaway blue ocean event happening in the Arctic. And that was, we had this huge dip in sea ice, I believe in 2012, where the summer sea ice in the Arctic fell to an all-time low. That's yet to be matched all these years later. So these sort of climate feedbacks that are going to happen after we lose more sea ice are certainly in our future, and so are other things like the AMOC, right? So what can you say there, right? We have the AMOC collapse that may make it a lot colder in certain parts of Europe, but then we have the loss of Arctic sea ice that could change albedo and make it a lot hotter, right? So, I mean, that's part of the chaos that's happening right now that makes even the near-term future, so challenging to predict. So, stick with the models right now and adapt as more information comes in. And so, yeah, I think it's a great question. I don't have a specific number to attribute to them.
Okay. Here's a question from Herb. And of course, you're under no obligation to answer it, but sometimes people are curious. Herb says the climate can return to below 1.5 C in the coming decades through aggressive deployment of solar radiation management techniques such as SAI, marine cloud brightening, and MEER techniques. Do you support SRM to directly cool the climate? Herb is wondering.
I mean, we're already doing it, right? Not in the right direction. I mean, we're managing it in the wrong direction. There was an interesting article that just came out, and it reminded me of you guys. I don't know if you saw the article about the white roofs, and essentially what they said is that the roof whitening was creating kind of local drought right outside, and that it can create regional drought. And the unintended consequences part of this is huge. What I would say is I support research into the question, because I just support research in general. And without good, robust information, I can't have an opinion. And unfortunately, there's far too little. Not only is there too little research, there's too many obstacles to that particular flavor of research, just based on termination shock, I think, is the generic reason for that. Once we start this, we have to keep this up. Should we stop it at some future point, who knows what'll happen. And the MEER reflection project, I think early on, I don't know how serious this was. The idea was to deploy enough mirrors to actually counter, bring us back to some previous climate point, right? Through just mirror reflections, right? And I did a calculation, and it was confirmed by somebody, someone in your group, that to return the Earth right now, because of our decrease in albedo, to come back to the albedo we even had in the year 2000, we would need to construct a band of mirrors, right? 92% reflective reflection efficiency, 150 miles wide at the equator circling the Earth, right? So essentially, the amount of albedo we've already lost is that large that just to return to 2000, we're talking about 150 miles, 75 miles on either side of the equator around the entire planet. So in practical terms, SRM is going to be so much larger than we think it is, right? To even get us back to a relatively recent stable point. And the more we move away, the more we move towards these tipping points and these sort of chaotic states, the more difficult that's going to become as well. But I always support the research.
Right. Yeah. Okay. Well, thank you. Thank you for that. Here is a question from Kevin. I accept that global warming is accelerating, so we have to fit a quadratic and we will reach 1.5 C in about 2027. If, though, we take into account a couple of extra things we know about. One, we were recently in an El Nino. And two, we have recently had some extra warming due to the banning of high sulfur oil in container ships, in which you mentioned. Does that change the mathematics slightly and mean that we will not reach 1.5 C until about, say, 2028?
So there was recently a publication. I wish I looked for the slide. I couldn't find it. I couldn't remember where I read it. That listed all of the major meteorological organizations' predictions for when we were going to reach 1.5. And the range was from 2027 to 2032, right? And they just, everybody had their spot in there. So I think it's fully possible. But, one thing to think about is that El Nino was not as strong as we think it is, right? It was not a particularly strong El Nino. It was certainly nothing like the 2016. It wasn't as strong as 1997. And yet we jumped above 2C a couple of days even out of that. We had extraordinary temperature rises. So, these sort of smaller effects or signals are giving larger and larger effects. We expected to have a La Nina. It has not yet materialized. NOAA just decreased the odds of it just recently from, I think, 65 to 60% and shortened the duration of it. So, we need to have a lot of things go right to not cross 1.5 C in 2027. So, yeah, I don't know. I mean, it's going to be sort of like a who cares if it's 2027 or 2028. That's much different than it being 2040, in practical terms, which is where it was just a few years ago. So now it's happening tomorrow. I mean, it's happening by the end of this current presidential 4-year term.
Yes, indeed. Here's a question from Marco. Everybody agrees on the first derivative of the temperature difference versus IPCC being always positive. Now, according to your calculations, also the second and third derivatives are positive. Is that correct? Is Marco getting this right?
He is, and again, let me just share this so that maybe someone can, at some future point, look at this. So taking the difference between today and 10 years previous, right, gives us this graph of very chaotic, noisy looking data for planetary warming on a decadal time scale. And if you take if warming was linear, then the trend line for this would be horizontal, right? I actually tried chopping this data up so that it didn't start in 1950, but it started in 1980. And even then I got a trend line that went up. I mean, acceleration is happening on any recent time scale. I want you to look in the far right of this. On the far right, this is what's been happening over the last few years. And you notice that pretty much since about 2012, we've been more like 0.5, 0.6, 0.7, right? I mean, the decadal warming in the last decade has been extraordinary. And that has actually helped pull up this curve. It has helped it be sort of more quadratic on the far end. Whereas, and just to be clear, like I have the R squared for the quadratic at 0.1488 and the R squared for the linear is 0.1476. And what that should tell you is that the cubic term has a very, very tiny coefficient. All right, that is if this is cubic growth, something cubed plus something squared and so on, that the coefficient in front of that cube is a tiny little number. So the jerk that's happening in the climate right now, if it exists at all, is tiny. And it's really a reflection of this last decade sort of extreme rate of rise. Now, why has the last decade gone up so quickly? Well, I mean, we just, it kind of, in some sense, doesn't make sense because we had 3 years of La Nina. That should be compared with 10 years earlier. You'd expect it not to have been that much of a rise for those years. But then we did have an El Nino in 2023 compared to 2013. So we would expect, a large gap. Any rate, I've actually had some people try and convince me that the current rate of warming is 0.6 C per decade. And they just want to focus on that little bit on the far upper right over there and say, aha, we're at 0.6 C per decade. That means we're going to be reaching 2.0 by 2030, right? And they'll get really like want to tell me that we're at 2 by 2030. And no, we're not going to, no. At any rate, I just had to, that's actually going out to 1 or 2 people who have kind of trolled me about this on social media. So excuse me for that. But yeah, as for the question, linear, quadratic, cubic, I think looking at the R squares and looking at that very recent data tells the story of where that comes from.
Okay, good to set the record straight for those following you. We have maybe 2 more questions, and speaking of the sun, from Peter, what is your perspective on the feasibility of stratospheric aerosol injection for geoengineering, given that suitable delivery vehicles do not currently exist and prominent figures like Gavin Schmidt have expressed skepticism regarding achieving global geopolitical consensus for its deployment?
I think I agree with exactly the premise of that statement. Yeah, I mean the actual numbers, I'm sure somebody has them available, but what do we need? Like 3,000 tankers flying 24/7, spraying this stuff into the stratosphere in order, it's some incredible number. I mean, what we really need is a series of volcanic eruptions that we have nothing to do with. They just sort of happen, in random regions that aren't particularly habited, have many people in them or life, and get some natural sulfur in there, have it happen for but I mean, the argument against it is that it gives us an excuse to not change, to postpone the transition, to put off dealing with fossil fuels in our economies, right? Because things aren't bad yet, so we have a few more years. So, some people say that it really gives permission to oil companies to keep on pumping oil. And, that by itself is argument enough against it. So I think that the feasibility question it's entirely not feasible right now in any realistic terms, but I still argue that we should do the research just because. And there was one climate scientist, I'm not going to actually tell you who it was, who said, if it gets bad enough, we can just start lighting off some nukes, like nuclear winter, right? It's like, okay, that's your solution to the climate crisis. And I mean, there is almost something to be said for that. I mean, that is a solution. We could do that today. We could just start lighting off nukes to throw dust and ash into the atmosphere. When you look at the rate of warming and use that in terms of, I use nuclear, Hiroshima bombs for the current rate of warming of the planet, and they get 10 or 12 per second, right? That's how fast the planet is heating up. I mean, it makes sense to start talking about how many nukes per second would we need to cool the planet. I can't believe I even said that, but
Wow. Well, it's not the craziest thing that's been said.
anyway, it wasn't my idea, okay?
Right, right.
The
I get
climate
it.
science, a well-known climate scientist said that.
Yeah, yeah. Well, that's kind of a good lead into one last question, because that's, more the grander scale of what people can do. But there is some curiosity about whether you yourself, or people are taking precautions, like, for instance, adaptations. What adaptations have you envisioned for yourself, for survival in a world that is above, these marks that we're talking about, 2C or whatever it ends up being as the, acceleration accelerates, moving to high altitude, I think, and again, you don't have to answer this, but some of us are curious. We want to know what we should be doing.
Yeah, I can't answer for anybody else. That's a very personal question, but again, I just want to, I think it's a generational thing. It must be. But what it means to be an environmentalist has completely changed in my lifetime, right? So when I was a kid, I was an environmentalist as a teenager. I went to Earth Day in 1977 at UC Davis. That was my first Earth Day. And back then, what environmentalists meant was to save the environment above everything else, right? Right. You were of course, we had lead in gasoline, we had rivers on fire, we had oil spills like crazy going on. And I mean, the environment was a mess. We had the ozone hole. So there were some easy pickings back then, I could say. And if you look back through environmental regulations, the early 1970s, there was easily a dozen fabulous, great laws passed that changed the environment to make it possible for humans to even be alive today, but for the actions that were taken primarily in the Nixon administration, if you want to know. To form the EPA and NOAA and Clean Air Act and the Clean Water Act and the Endangered Species Act and so on and so forth, right? So environmentalism has changed. Now what environmentalism it has become is, what do I need to do to save the planet so that humanity can continue? Do I need to switch from fossil fuels to an electric bike, an electric car, and solar, which might mean, okay, instead of fossil fuels, we'll have mines and we'll, clear cut hilltops, and we'll, have it's a discussion that I don't want to have. I mean, to me, the discussion is, why aren't we environmentalists, right? What has happened to the environmental movement? So my particular adaptation is 100% focused on the environment, right? It's like, what can I do at this time in my life for the environment? And there's personal choices I make with that, and if you read my bio, I walk, right? I walk. I don't want to. And now maybe if I was younger, I would ride a bike. I would never ride an electric bike because I don't like the lithium that mining that goes into those. So I walk to a grocery store 4 days a week because I can only carry so much, right? And it's about a mile each way. I live in a neighborhood with a lot of people who could be walking to that grocery store. And I might run into one person walking a month, to that store. I feed the animals that are around me, right? Yeah, I know they say you shouldn't feed wildlife because they become dependent. Well, these are not wildlife out in the hills behind me. This is wildlife in my yard, right? We have owls and skunks and crows and squirrels and birds of all type, mice, and I don't feed the rats. I try not to. Those are really food for the owls, I'm hoping, in general. So, in my own way, I'm trying to be an environmentalist, and I'm sort of an urban environmentalist. I have certainly some supplies in storage, assuming, that I'm going to want to be able to live a month or two without any power or water or whatever. So that's there. And when the first step is always civil unrest. So, we're 9 days away from anarchy, as the saying goes. So, you have to anticipate that could be in your future. I'm not sure exactly what I would do in that situation, but it's going to get very ugly very soon. And so what I would often say, or what I say for myself, is just do everything I can, do everything I can to save as much of the planet as I can for whatever it's going to come after humans. I mean, we're going to be here for not much longer. We might be here, according to some people on YouTube, we might be here 3 years. According to, others, we might be here 100 years. Civilization is not going to last much longer than that. I mean, in the most optimistic scenario, we're losing the coastlines and all the ports. So we're going to lose we're losing a million square kilometers a year of land that, that we can't grow stuff on anymore. We're going to, we're losing to fascist governments, and we're closing borders. And I mean, it's going to get really messy, and civilization is going to collapse one way or another. I'm not a human extinction type person, but that collapse is inevitable in the lifetimes of some of the people who are right here with us right now today. And it's a very sad future to sort of understand as inevitable. And the choice you want to make is not, should I try and bunker myself up with as many handguns as I can? It should be, what can I do to preserve as much of the world, the environment, nature as I can, while I'm here. And that's sort of the position I take on that question.
Yeah, yeah. Well, I think that's inspiring and reminds us that we can often walk to places that we are not using, that we're driving to and so forth. And we do have choices, daily choices that we can make that have an impact. So we want to thank you so much for coming and sharing the incredible slides with graphs and so forth. That was really enlightening. And we also just want to mention your recent book, The Blackjack Zone, Lessons in Winning at Blackjack and Life.
Hold it.
Not
If you're
just
gonna,
blackjack.
no,
Oh,
no,
oh,
no.
good. You're going to show it.
That one's from 2005. This is
Oh, you have something.
This is my 2015 book. This is for anybody who wants to beat a casino. I worked for the casino industry for a decade, and I figured out all the ways to beat all their different games. And so I wrote this book. It's 500 pages on how to beat casino games. It's not card counting. It's all the other ways.
Okay, so everybody
that's the
can
book.
go beat the casinos and then use the money for the good of the
Yes,
environment, right?
absolutely.
Well, thank you so much for coming, Eliot.
Thank you.
At MEER, we are working to help educate the public while also developing a solution to the warming on the planet. We invite you to keep learning about Earth's energy imbalance and climate science on our website, meer.org. We are primarily a volunteer staff, so please do consider making a monthly donation of any amount that works for you. And tell somebody else about MEERTALK. You can check out previous MEERTALKs on our YouTube channel, and you can, of course, see us on social media. So we hope to see you again for our very first MEERTALK of 2025 with Richard Heinberg, and Richard will be our guest speaker. So until then, take good care. Look for our mailings about dates on that. And thank you so much for coming.